This should not be like that. Okay, but report should be as per the requirement. Okay, শুরু করি নাকি? বাকিরা this only 11. ঠিক আছে। জল নেই ট্যাঙ্কে। চালিয়েছি। Okay, so sharing my screen. So screen is visible to all?
Yes sir, the screen is visible.
Yes, sir. Okay, so today we'll talk about the calibration of V-notch. So V-notch and IRs, those are used to measure the discharge over an open channel flow. Okay, so I think you have studied in your fluid mechanics class, na? V-notch, IRs. So this is basically used to measure the discharge. যে তোমার পড়ানো হয়েছে না হয়নি? V-notch, IR.
Hello sir, basically sir I am from lateral entry, so I did not study the V-notch and wire push.
Lateral entry means diploma, no? So
yes sir, yes.
But you have studied the open channel flow, no? In your diploma. Open channel flow.
Yes sir.
Sir, V-notch ছিল না আমাদের মনে হয়।
স্যার ওপেন চ্যানেল ছিল।
Okay.
পাই ফ্লো এগুলো ছিল, V-notch ছিল না।
So okay, before going to the demonstration, I will give you the brief introduction of the subject. You will understand. So how to measure the discharge and its theoretical background. Okay, so here objective is or are to calibrate a V-notch wire and also to determine the coefficient of discharge. Just a second. And to determine the coefficient of discharge, CD. And what is CD we will discuss. And here in the demonstration I will show a channel with a V-notch, collecting tank or volumetric tank, and piezometer and stopwatch. So those are the things will be shown in the demonstration, and how to do the calibration, what is calibration, I will discuss here. Okay, so but before going to that, I will take a few slides to show the theory. So here this basically document or the PPT, all the information has taken from this book. So this is basically R.K. Bansal, a textbook, and this book is available. Soft copy is also available on net, and you can take the PDF. Okay, so notch and wire. So notch and wire are used to measure the discharge basically. So a notch is a device used to measuring the rate of flow of a liquid through an open channel or a tank. Okay, so it may be defined as an opening in the side of the tank or a small channel in such a way that the liquid surface in the tank or channel is below the top edge of the opening. So it will flow over the particular section.
আমি কি এটা পড়ে গেছিল না
And
স্যার কি দেবো
so where is a concrete or masonry structure, it is larger than the notch placed in an open channel over which the flow occurs. So this is the larger portion, and it is generally in the form of vertical wall with a sharp edge at the top running all the way across the open channel. So if you have a large open channel, so it will be simply a vertical wall, and water will flow over that wall, and it will maintain a certain thickness of the liquid that will pass over the notch. And the notch is of small size while the wire is of bigger size. The notch is generally made of metallic plate or wooden plate, while the wire is made of concrete or masonry structure. So when you have an open channel like a say in the irrigation sector, oftenly will use the channel, open channel. So suppose and you have an hydroelectric dam and you have big reservoir, and to help into the cultivation or in the agriculture, people will do some channels. So channel will carry the water a long distance, and it will help in agricultural activities. So to measure the volume flow rate through the channel, so you will place a particle wall for the channel, and water will flow over the channel, and so by measuring only the thickness of water that will pass over the notch, you can estimate the volume flow rate. So not only that, you have heard in case of any dam, say DVC or Panchayat, so they will discharge the huge amount of water during the monsoon to prevent the dam. So they are telling like this 3,000 or and 1 lakh cubic amount of soil and water will be discharged. So, but how they are measuring this large amount of volume flow rate? So they simply measure the height of the water level, and that will over the spillway. Basically, there will be a certain section of the dam, and through which the water will pass. Not only that, in the river also they will give some an indication, say green, yellow, or red. So red means so there will be a large flow. That means height will be more. So based on that understanding, here we will discuss and some of the measuring equipment or say device. So those will be utilized for the measurement of the rate of flow or discharge. So there is a two term, nappe or vein. The sheet of water flowing through a notch or over an wire is called nappe. So there will be a certain thickness, so depending upon the flow rate. And crest or shield will be the bottom edge of the notch or the top of a wire over which the water will flow, is known as seal or crest. So these are the two nomenclature. But how we'll calculate the discharge based on the thickness of water that will pass over the wire? So there are different types of notch and wires are available depending upon the shape of the opening. So your opening shape may be the rectangular or triangular or trapezoidal or step notch. So depending upon the shape, so there are the different types. Now come to the theoretical background, how we will estimate the discharge or volume flow rate. So look at the figure. So this is a rectangular notch. Shape is basically a rectangle. Okay, and this is basically the sheet of water that will pass over the wire or notch. So here, so there is a thickness. So here it will pass through, and it will come down to the below based on the height. But our intention to measure the discharge. So discharge is nothing but that is the area into velocity. So area means the flow area, and velocity, and that is mostly the average velocity. So you know that flow through pipes is basically A into V, that is the volume flow rate in the form of meter cube per second. But in that case, we will consider the velocity should be average velocity. But you know that when the flow will take place through a pipe, velocity at any section will be different. So, and you also know that at the center of the pipe, you have the maximum velocity, but at the wall of the pipe, so there is no velocity. And this, so velocity profile is oftenly you will get as a in the form of parabolic profile. So velocity will vary with the distance or the height. Similarly here, if you think for the open channel, here the velocity at the different location, if you consider near the crest, so there is no velocity at the crest basically, so there is no velocity. But when it will go up, you will get, so velocity will vary with the height. So there will be a change in the velocity. So, but our intention to measure the average velocity. So how to do that? So when there is a change in the a certain parameter with the, say, height or radius, what we do? We do the integration. And to consider integration, we need to consider some elemental thickness. So here we will consider an elemental thickness of, say, dH. A is distance below the free surface. We will consider A is distance below the free surface. Then what will happen? So there will be a variation in the velocity. So we will consider this elemental thickness of dH below the H. Okay. Then we will initially measure the discharge through this elemental strip of thickness dH. And to calculate the total, we will do the integration from this 0 to H. So this is the total H. So we will consider this should be 0 to H. So based on this understanding, we will consider initially like this dH. So L into dH will be the area of the strip. So this is the thickness and this is the length. So area of the strip will be LDH. Then velocity or through the strip. So what will be the velocity through the strip? So here you consider, so there is a small opening through this strip. Then what will happen? So due to this height, a certain velocity of water that will come out through this strip, very thin strip, and that is directly proportional with the root over H. So you will get the velocity, the theoretical velocity through this
ইনিশিয়াল ভেলোসিটিটা 0 থাকে না যখন থ্রু দা স্ট্রিপ জলটা পাস করে থাকে, মানে এখানে যে ভেলোসিটিটা নিচে এটা তো মানে ফাইনাল ভেলোসিটিটাই √2gh।
হ্যাঁ, that is coming out, say basically you have height here, this is H, so this is the free surface, no? So you're opening below this H, so this potential energy will, or the potential head will be converted into the kinetic head. Clear? Understood?
হ্যাঁ স্যার।
Okay. Now, based on this understanding, And if you consider the discharge, so this will be the area, flow area, and multiplied with the velocity. So this will be the theoretical velocity, and discharge through the strip will be the flow area multiplied with the velocity. And here there is a coefficient that is called the CD. And we are multiplying this CD to have the actual discharge through this strip. So CD is the coefficient here. And coefficient of discharge is nothing but that is the ratio of the actual discharge divided by the theoretical discharge. So here basically to get the theoretical discharge, we are considering the basically potential energy completely converted into the kinetic energy based on the boundless theorem. The boundless theorem is only applicable for the ideal fluid, but you know that, so no other, we will not get any fluid, so those will completely behave like an ideal. So there is a certain viscosity. Okay, so CD is the coefficient here. So this is a discharge through the strip only. Now, if we consider the discharge over the entire or notch, so then we need to do the integration over this 0 to h. So if you do the integration on this L root over 2gh into dh, so finally, and you will get a relation of the discharge, and that is directly proportional with the h to the power 3 by 2, and the other parameters are basically constant. Okay, so this is basically the formula. So here, based on the measurement of this h, and you can measure the actual discharge. So only we need to measure the height or sheet of the water that will pass over the wire or notch. Okay, so got the idea?
Yes, sir.
Yes, sir.
Okay, so here CD is basically give you a parameter that will, so without CD your relation is coming as a theoretical discharge, and multiplied with some coefficient you will get the actual discharge. So it will give a relation between this actual discharge as well as the theoretical discharge. Okay, so using the formula you can calculate the theoretical discharge, but multiplying with the CD you will get the actual discharge. So in our demonstration or the experiment, our intention to determine the CD. So when you will purchase a V notch, in that case they will provide the CD. Okay, so by measuring only the height and multiplied with the CD, we can directly estimate the actual discharge. So that is our intention. So understood?
Yes, sir.
Yes, sir.
Okay. So this is based only for the rectangular notch, but in our demonstration we have the triangular notch or V notch. So triangular notch, and sometimes it is known as the V notch. It is look like a V. Okay. So we will do the derivation in a similar way, but in the earlier rectangular notch, so there is width of the notch fixed in the form of B, but here you have the dimension only a theta, so that theta will be given. Say this, so theta may be the 90 degree or 60 degree or 80 degree, whatever. So here you have the dimension only theta is the dimension. So we need to consider an element and strip with some thickness as well as width. So initially we need to estimate the width first. So and how to do that? So you take the help of the trigonometry. So this is basically the theta by 2 is the theta, and it's the theta by 2. And here, so this strip is placed h distance below the free surface, and total height of the notch is h. Okay, say here OC, and we are constructing two triangle, and here OC is nothing but that is ace minus small ace. It's capital minus capital Ace minus small h. Okay, now so this is a similar triangle here. So you can think theta by 2 is nothing but that is a AC by OC. Okay, OC will be Ace minus h. Okay, and AB is nothing but that is a twice AC. Okay, so you can estimate AB or width of the strip in the form of an angle theta by 2. Okay, so now we have the area of the strip will be multiplied with this thickness. This is the width multiplied with the thickness. So we will get the area. So understood how we are getting the width and the area of the strip?
Yes, sir. Yes.
Yes, sir.
Okay. Now, in a similar approach like the earlier one, we will get the theoretical velocity of the strip. Or through the strip will be root over 2gh. So distance through the strip, that is the area of the strip, and multiplied with the theoretical velocity. Then we need to do the integration. So this will be the distance through the strip, and total distance we need to do the integration over 0 to h. So here we have the h here, so that is why it will be slightly complicated, not the complicated like that. So basically here it will come h, so this is h by 1 by 2. So finally you need to do the integration and you will get an similar type of equation, but here you have the so this is also so directly related with the height or height or h, that is a h 5 by 2. So here, and if you know the theta and other components, so q directly will be estimated by measuring the h. Okay, say here you have a standard, so this is a 90 degree theta, so this will be the, so directly you will get a correlation to estimate the actual distance based on the measurement of this h. So h is a measuring parameter and q is the calculating parameter, and that is the actual distance. Okay, so based on the measurement of this h, we will calculate the distance. So understood?
Yes.
Yes.
Okay, so based on this theoretical understanding, so there will be a say we have discussed two type of notch. One is a rectangular notch and another is a triangular notch. So what are the advantages of this triangular notch over this rectangular notch? Basically, if you think on this figure, so here you will get basically variation of, or if you will get more basically height. Suppose if you want to measure the less distance, in that case, in case of rectangular notch, this height will be very less, and already you know that, and if you have a less dimensions or it may be few millimeters, it is very difficult to measure few millimeters instead of few centimeters. So here, and if you have the fluctuation in the measurement, so your V notch will be so better than the rectangular notch. But on the other hand, and if you have a fixed large volume fluid over a certain period of time, in that case, rectangular notch is also okay. So it will give you better or more accurate result corresponding the rectangular notch. Okay, so these are the things are there. And for the trapezoidal notch, so this is the trapezoidal notch. So most of the natural or the basically the channels or the open channels are shaped like this to have the better structural benefit, not the like the rectangular shape. So these are basically the liners of the channel. Okay, so these are the things you will learn in your fluid mechanics, I think so. Okay, so now come to the demonstration part. So here these are the different channels, or that is a notch based on the shape. P notch, rectangular notch. So this is the triangular notch. So this is the theory. Already I have discussed how to establish this relation to calculate the distance by measuring the height. So here you will get an schematic diagram of the experimental setup. So here we will create an open channel flow using a pump. So in a laboratory you need to create the flow. So there is a centrifugal pump, and this is a sum or tank or reservoir. So this is a pump. They will lift the water through this discharge pipe, and it will come here. Then what will happen when it will fall up from a certain height? So it will initially create some turbulence, or it will give some undulation. So to get or to stabilize the flow, or to have the similar like the laminar flow, so there will be a number of screen mesh. So these are basically porous screen, and flow will pass through this screen. Then what will happen? So we will get more or less a streamlined flow. So basically our intention to measure the height, na, so fluctuation or the so there will be no fluctuation on the top surface or free surface. So that should be minimized. So here there will be a piezometer, so that will give you the location of the free surface. Okay, so this is the notch, so that was placed side of the channel, and then what will happen? The water will pass through this notch, and it will come to the tank, and that is called the volumetric tank. And in the volumetric tank there are two chambers. So this chambers is basically directly connected to the sun. So when the water come here, and this is called the deflector. So function of the deflector, it will change the position to fall the water from this chamber to this chamber, or when you will do the measurement, you will take the water to this tank. So there will be another piezometer here. So this is basically a certain volume, or certain, basically you know the area, and when the water fall here, and you can simply able to measure the volume, a certain volume, and you will take certain time, and basically you need to measure the time to fill a certain volume. But on the other hand, it will basically, when you will not take the reading, so your deflector position will be this chamber, and it will create a so it will come to the sum, and it will create the complete cycle like this. So it's continuously there will be a flow. Okay, so but this tank, when you collect, so there will be an initial height, and say you will take say time for the 2 minutes or 3 minutes, and within these 2 or 3 minutes, so there will be a rise in the head. So you will get the final minus initial, you will get the height, and if you know the cross section area of this tank, so area into the height, you will get the volume, and divided by the time, you will get the actual discharge. So by using this volumetric tank, easily you can measure the actual discharge based on the volumetric principle. You will collect a certain volume divided by the time. So understood?
Yes, sir.
Okay. So so in this case, your measurement basically parameter is two height only. One is for the piezometric with height for this notch. So this is the initial and this is the final, and you will get that is capital H for the notch, and there will be another header height for the volumetric tank and time. Okay, so now another thing will come into the picture. You need to vary the discharge, but how? So here, and you have a centrifugal pump, and that will create a certain amount of discharge. Now, if we provide a bypass valve here, so bypass valve means, suppose this valve is completely closed, then what will happen? So entire amount of water will go to the channel. Okay, but if you partially open it, then what will happen? A certain amount of water you will do the bypass through this bypass valve, then there will be a variation in the discharge through this main channel. Okay, so by controlling this bypass valve, we can vary the volume flow rate over the channel. Understood?
Yes, sir.
Okay, so bypass valve will be we will control the flow rate or volume flow rate. So any confusion on this setup? No confusion. Thank you. So now I will show the video clip for the setup. Just a second.
প্রিন্টটা করিয়ে নি
Drive. This is the 2-1. This is the 1. But before going to that, I will show the instruction sheet. That is also vital. Just a second. So this is the instruction sheet for the calibration of V-notch. So you need to write your name, roll number, class, section. Okay, and there is so this is the formula or equation we will utilize for the calibration. So that derivation I have shown to you. So this is the observation table. So this is the reading of the V-notch. So we will get the number of runs, say 5 or 6 runs. So initial, there will be an initial, that is the location of the crest. So the final. So final minus initial, you will get the difference, and that is a capital H. and there will be, and this is the reading for the volumetric tank. So initial and there is a final. So final minus initially will get difference, and to have the difference or to get have certain difference, you need to measure the time using the stopwatch, and then only step by step calculation to calculate the CD. And for the 5 reading, you will get the mean. Okay, so this is and now come to the demonstration. So this is the, so these are the initial position of the crest. We need to measure the final one. Here we will take a 6 reading. So this is a volumetric tank. So this is the notch. So we will pass through this notch. So this is the piezometer for the volumetric tank. So this is the initial position of the piezometer. So this is the initial for the volumetric tank. Then, so they are controlling this deflector, so flow will not take place to this volumetric measuring tank only. Now, with a certain time, now so only water will pass to the bypass line. So there is a section it will not come to the measuring tank. So you will collect a certain amount of volume to the measuring tank. Now final height will be say 12 centimeter. The initial was 9 around. Okay, so difference is the 3 centimeter. Multiply with the area and you will get a corrected volume. Now here this is the final height or head of the V-notch. Using the piezometer. So difference is coming 5.3. So this is a single reading. Similarly, I have another reading. It will show the second one. So this is a bypass line I have told. So this is a bypass line. So initially a large amount of it is coming to this bypass line, but slowly he is controlling this flow. So more amount of water will pass to the main line to the channel. So this is the bypass valve. Are you there, na? Hello. So are you there?
Yes, sir.
Okay.
Yes, sir, we are.
So at the volumetric tank, some of the wooden blocks are there. So why these things are there? I will tell you later. So this is the second rating. So now you can see the whole amount will pass to this channel. Okay. So this is the demonstration. So any confusion or any question on this?
No, sir.
Okay, very good. So now come to the. So this is about the demonstration. Then I have shown the instruction sheet, and now finally I show the data sheet of the entire PNOS data. So I will hand over this sheet also. So you will write this data. So they have taken the 6 number of data set. Okay, so only you need to calculate the CD and determine the mean CD, that is average. And here you need to plot the two things, that is Q versus H in log paper and CD versus H, to check whether there is any variation of CD was there or not in with the change in the H. Okay, so here the CD is basically the calibration parameter, and if there is a change in the CD is there with the H, and that correction you need to take when you calculate the misses using this formula as well as this notch. So it means that a discussion, there is a term was there, this is called the discuss about the effect of velocity of approach on the discharge and the utility of the calibration curve. So utility of the calibration curve is to get the accurate measurement, and if there is a variation is of CDs there or not with the H. Basically, you will measure the H, na. So if there is a variation of H, CDs there in the variation of the height, and that correction unit or that value, basically when you have a curve, so you will get the different value of CD at the different height. So based on the height, initially you need to take this CD first, then put into the formula, you will get the actual discharge. But what about the velocity of approach? Now, if you go to the this lecture here, I will show. So when you have a flow through this channel, so basically flow, so there will be a motion of the liquid. So there will be continuous of motion, or there will be a velocity of the water that is coming toward the notch. But when you will do the analysis, only we have considered the height will be converted into the velocity. But initial velocity towards the notch we have not considered. Okay, so only we have convert the height into velocity. Basically, v is equal to root over 2gh. But towards the velocity, towards the notch, there will be a certain velocity. So basically, the actual velocity will be slightly more than that, the theoretical velocity we have considered. Okay, so that is known as the velocity of approach. So got the idea or understood?
Yes, sir.
Yes, sir.
Okay, so when you consider the velocity of approach, obviously the theoretical distance will be slightly more. Okay, so that is the discussion. So, and similar like the earlier PPT, you need to draw a schematic diagram, and that already I have shown here. So similar kind of schematic diagram we have to draw in your free hand. So don't copy this one, okay? So draw in your own hand and write. Okay, and sample calculation, plots, and discussion. So this is all about the report. So not only that, keep your so these are the report shoot you need to carry during the viva. So there will be grand viva at in your say 7th semester or 8th semester. There will be a grand viva or comprehensive viva. So during that time you need to carry those reports. Basically, in the earlier practice, you have the so those are the hard copy but you have the soft copy now for the 2 years. But in the earlier practice, so they will carry, your student will carry the reports to the viva, and they will show, and teacher will ask some questions. So this is the common practice. So these are the verified documents. So you need to prepare the report clearly. Okay. So you are the engineer. Report should be clear, and based on the report, you can understand what you have done in the lab. Okay. So prepare the lab sheet, and not only that, at the lab sheet you have the marks. You have a certain amount of marks, and it will be based on the report as well as viva as well as attendance. So we have a number of divisions. Okay. So if you have any questions, and you can ask.
So we have to print out that observation table, and we have to put
the okay. So তারপর তো একটা schematic diagram, sample calculation, those are the things you need to write. Okay. Or 5 or 6 pages, okay, maximum.
Okay.
And you need to attach the instruction sheet also in a single file, a single PDF file. Okay, and no need to copy anything from this in the instruction sheet. Okay. So only the formula, so that I have shown here, only the derivation of this formula. So this, so only this derivation are the theory, huh? So this is a formula. They will so derive at the theory section. Okay.
Okay, sir, understood.
Okay. Chalo. Thank you. So only